A case structure can conditionally determine blocks of code to execute based on an input. For you text-based programmers out there, this is similar to an if-then else, switch, or case statement. Now, what determines what will execute? In this case, it's this Boolean control that we see right here. And here's the corresponding Boolean switch on our front panel. Now let's head into LabVIEW and see how to program this. I have a new blank VI, and I'll hit Control-T to tile these, and head to my block diagram. I'll right-click, go to my Structures subpalette, and head to Case Structures. You see, when I click on that, my cursor shows a little miniature case structure. So I'll click in the upper left corner of where I want to build my case structure, drag and release, and I have my case structure. Now the cases in a case structure are stacked like a deck of cards, so that I don't see the underlying cards when I'm looking at the topmost one. Let's think of a simple use case. Sometimes I need to take two numbers and add them together, and sometimes I need to take the same two numbers and subtract them from each other. So let's do that. I'll head to my front panel, bring up my controls palette, and go to a default numeric control. And it's called numeric by default, but I'll change it to number 1. Then I'll select it, hold down Control, and now I have number 2. So I'll click, drag, highlight both of them, go to my Align Objects tool here in the toolbar, and align them to the left. That looks great. And I'll head over here to my numeric indicator to put down our result, which I'll cleverly name result. Heading to the block diagram, I'll take number 1 and number 2 and put them here to the left of the case structure. And I'll take result and put it right here to the right of the case structure. Now this green thing right here is called the case selector terminal, and it determines which case will execute. I'm just going to click directly on it to move it down here. Out of the way for right now. Our requirements are to sometimes add these two numbers together and sometimes subtract them from each other. So I'll go to my false case, and let's say in my false case I'm going to go to my numeric palette, to my add function, and add these two together. And now I'll wire number 1 to the top terminal of my add function, and number 2 to the bottom terminal. Now we can just flip over to the other case just by clicking this little arrow, and we notice that in the true case we don't see what's in the false case. Again, deck of cards, we don't see what's in the other cards. So in this true case, I'm going to again go to my numeric palette and pull out the subtract function. Put that there. Now to subtract these two numbers, I'm going to wire from these tunnels. You see these orange blocks here are called tunnels. Whenever I wire into or out of a structure, I automatically get a tunnel. So I'll just click on the output of the tunnel and wire to the inputs of my subtract function. The color, of course, of any tunnel will indicate the data type it represents, just like the wire. And since we have orange blocks and wires, we know that's a fractional number, the default being a double. And now to finish, I'll just wire out from the output of my subtract function to my result indicator. Now as I wire through the border of the structure again, you see a different type of tunnel arises. And it's a hollow tunnel. Now what do you think that means? It means that we've supplied an input to the tunnel in one case of the case structure, but not in the other. So let's do that. Wire directly to the tunnel, so it's flashing. There we go. Now we're almost ready to run this, but we have a broken run arrow because we haven't yet told the case structure which case to execute by supplying an input to the case selector terminal. The color is green, and so we know that that's a Boolean data type. So I'll head to my front panel, go to my Boolean subpalette, and put down a vertical toggle switch. On my block diagram, I'll take that terminal and wire it directly to the case selector terminal. We have a solid run arrow, so we're ready to go. So let's test this out. First, in our false case, we should be adding these two numbers together. So I'll fill in some values. Number 1 gets 3, number 2 gets 2. I'll keep the Boolean as false and run my VI. As we can see, 3 plus 2, 5. I'll go back to my Boolean using my operate tool, hovering directly on it, click, turn it to true, run again, and now they're being subtracted. Numeric 2 from numeric 1, as we see over here. Now let's see this in action. I'll slow this down using highlight execution, which is the light bulb. Click on that, and change this Boolean back to false, run it, and we see that we execute one in only one case. The Boolean is red, telling us we're going to the false case. We execute the false case, and then we're done. Now what we've just done is exactly equivalent to an if-then statement in text-based coding. And we'll see that in the future, I'll be able to wire different data types to the case selector terminal, and it will change my available cases to run. Instead of just having true and false, I can have multiple cases, maybe numbered, or maybe with different labels. This is based on the polymorphism of our case structure. And we can see that with those different data types, we can have as many cases as we'd like, offering us quite a bit more flexibility in our coding. But for now, you'll do our next exercise. If you have a copy of LabVIEW, go ahead and open that up. And then open up the test drive PDF manual. In there will be instructions on how to complete the exercise. When you're finished, there's solution code in LabVIEW for the completed VI. Additionally, there's a solution video, which has me walking through each step of the exercise and showing you how to do it. So there's never a chance for frustrating confusion or delay. Additionally, in the solution videos, there are other tips and tricks, as well as productivity tools that will help you become a more efficient LabVIEW developer. So take a look, and good luck.